Good afternoon and welcome to AP Stats. We're going to continue our Titanic lesson. In fact, let's go down to the last problem that we didn't do, which I think was right down here. I'm just going to, for period 6, just going to clear out what we have over here. So as we take a look at what you did on page 4, it says, well, first of all, is this the last problem that we didn't do? I just want to see. Yeah, because we just didn't do any page 4, did we?
No.
Did we complete page 3?
Yes.
Yeah, we did. Okay, so that's what I thought. So we are at the beginning of page 4. And I'm just going to grab my stylus. So here we go, page 4. And on page 4, we've got the same Titanic data, but this time, we're going to find the distribution of the conditional relative frequencies of class for all categories of survival. Before we were finding the distribution of relative frequencies of survival for all 4 categories of class. So our distributions were set up vertically, but there's nothing special about vertical. We can go horizontal. So the distributions will be laid out like this, and hopefully this will set your minds and hearts at ease in case you were wondering, why were we doing our work vertically? Like 2 over 3 over 325, 122 over 325 to get a distribution here. Why do we use the bottom margin? Why don't we use the right margin? We can use the right margin. So on your calculator, what I'd like you to do is find this percentage by telling me, what is 203 divided by 711? Just use your calculator, divide, move the decimal point 2 places, and what do you get? Round it to the nearest percent for that number. Sam, do you have it already? No, you're still reaching for, yes. Yes, go ahead. So about 29%. So that means that 29% of what? It means 29% of the living were first-class passengers. Before, when we found that 62% right here, we said 62% of first-class passengers were living. Now we're going the other way. 29% of the living were first-class passengers. Fill in these other 3. What percent of the living were second-class, third-class crew? And then do the same thing for those who perished. What percent were first class, second class, third class, and crew? So fill in those other 7 numbers on your own. I'm going to press pause while you wrap that up. Okay, and actually, I just noticed something was going on with the camera. I just want to summarize what we did so far. So what we did was we took these numbers up here. We took 203 over 711, 118 over, so we found out that 29% of the living were first class, 17% of the living were second class. So these distributions came out to be not equal. Why? Because, for example, 8% of the dead were first class, 29% of the alive were first class. Had they been independent, those would have been equal. Now what we're doing is saying, what should it have looked like? Who can tell me what the marginal distribution of relative frequencies was? It was 15% of everyone overall was first class. Who's got second class for me? Crystal, do you have that?
13%.
Yeah, and that's just from a previous day. We'd already calculated that. Keep going.
33 and 40.
And 40%. See, if survival is independent of class, then since overall 15% was first class, 13% second class, etc., you would have expected for those who had perished that 15% of the dead would have been first class, 13% of the dead would have been second, 33%, and 40%. And unfortunately, I didn't have the camera on when we looked at this previously. A very common incorrect answer is to think that all of these should be 25%, because 100% divided by 4 is 25%. But that's a mistake. It would only be all 25% if 25% of everybody had been first class, 25% of everybody had been second, third, crew, etc. So don't make that common mistake. Now, just this last thing, in the hypothetical situation, what would these have looked like? And this also, to be honest with you, is a quartet of numbers that you've already calculated, because we did a group formative assessment problem on this. So go ahead and fill in these 8 numbers. In the hypothetical situation, what would those 2 conditional relative frequencies have looked like? Give you a chance to fill those in. When you're done filling those in, you can look up here to see if we agree. They should both be 10, 20, 30, 40, because overall, the percentages at the margin were 10, 20, 30, and 40%. So that's what it should be in the event that they have been independent. So those are the 4, that's the 4-page handout. Now what we're going to do is check to see, do you know how to write the 3 sentences? So I have an activity for you that involves writing 3 sentences on a blank sheet of paper. I'm going to pause the camera here. All right, here we go. So on your sheet of paper, I would like you to, and we're just going to change the context here. We're going to have a little bit of fun with this and take the city of Anchorage, Alaska. Now let's do Tempe, Arizona. Tempe, Arizona. All right, and although it does sound like we might have a question. Crystal, did you get your question answered? Is that all? You got it straightened out? Okay, all right. So let's change the context. On your blank sheet of paper, I'm going to give you a distribution of conditional relative frequencies of one variable for all categories of the other variable. And the 2 variables, instead of survival and class, this time the 2 variables will be weather and temperature. Weather and temperature. And there's going to be 3 categories of weather, say categories A, B, and C, and 2 categories of temperature, categories 1 and 2. Now, here's what they mean. A is a rainy day. B is a snowy day in Tempe, Arizona. Okay, we have to use our imaginations here. And then C is a no precipitation day, a dry day. So it's either raining, snowing, or dry. And you might be wondering, well, what if it rains and then it changes to snow all in the same day? What if it's a rainy and a snowy day? What we're going to do is whichever it was first. So started out raining, then we'll say it's a rainy day, even if it changes to snow. Okay, and then for the categories of temperature, every day the temperature is either above the historical average, above average, or the average temperature for the day is below average. It's a below average temperature. Yes, average is used twice in that concept. And so suppose that someone went through and looked at all of the rainy days and found that of all the rainy days in Tempe, Arizona, 80% of those days, 80% of those rainy days were above average temperature, and 20% is below average temperature. Which, if you think about it, is kind of bizarre, because you'd think that rain would bring the temperature down. Apparently not in Tempe, Arizona. You like they have really hot, it's like, sauna type rain. It's so hot up there when it rains, like, ooh, it's really hot. Okay, and then on the snowy days, 10% of the snowy days had above average temperature, and 90% of the snowy days is below average, which is even more bizarre, because usually when it's, snowy means it's like kind of like a warmer day, relatively speaking, because when it gets really cold, it doesn't snow that much. Have you ever noticed, like, when it's 40 below, you don't get much snow? Not in Tempe, Arizona. And then on the dry days, we had 41%, of all the dry days, 41% of them were above average temperature days. Above average temperature, and I guess that has to be 59%. So I'm not giving you the counts, I'm just giving you the final distribution of conditional relative frequencies of temperature for all categories of weather, all three categories of weather. Now, what I'd like you to do is answer this question in 3 sentences. And you know how sometimes we use language of independence and other times we use language of association. Well, on the homework that's due tomorrow, you have to use the language of association. So let's practice doing that right now. Let's answer this question. In Tempe, Arizona, is weather associated with temperature? Is weather associated with temperature? Now, please write all 3 sentences. I'm going to pause while you wrestle with that a little bit, and then we'll come back to it. So, okay, the camera's back on. We're just going to regroup here for a second, see how you're doing. So for this first sentence, are you going to say that in Tempe, Arizona, weather is associated with temperature or is not associated with temperature? Yeah. It's got to be in context. College Board will change an E to a P if you don't write in context. If all you write is, if you don't mention Tempe, Arizona, and the variables weather and temperature, then your E, basically, you get half credit. E comes down to a P. In Tempe, Arizona, weather is, okay, who can tell me? Is or is not associated with temperature?
Is associated.
Okay, so Sam's saying that it is associated with temperature. Raise your hand if you would agree with that phrase. It is associated with temperature. So not independent and is associated with the same thing. That's correct. So that'd be the first part of your first sentence. Is associated with temperature because who can give me the because phrase? Take a volunteer. Maybe you know for sure that yours is incorrect, but yeah. Lydia, go ahead.
The distribution of conditional relative frequencies of temperature is not the same for all categories of weather.
Okay, so that's actually good work because a lot of people were wrestling whether to put temperature first and then weather, or weather first and then temperature. But what Lydia said was that because the distribution of conditional relative frequencies, she said of temperature, which is the correct choice, is not the same for all categories of weather. Good call. That's the first sentence. That's the hardest one to get. Any questions on the first sentence? First of 3. Okay, so then you got to decide which is, are you going to compare 10 to 90 or 10 to 80 when you do the second sentence? Yeah, we don't compare 10 to 90. You would compare 10 to 80. I mean, yeah, 41 to 80, those are different, but the most eye-popping difference of things that are supposed to be the same is that's only 10%, this is only 80%. So use 10% and 80% in your second sentence. I'm going to tour the room to see how you're doing on that. Let me pause the camera while you construct sentence 2. In your second sentence, if you're going to compare 10% to 80%, then you've got to remember that whenever someone uses the phrase percent, that you have my permission to ask percent of what? Because sometimes we're taking the percent of a number in the lower margin, sometimes it's percent of a number in the right margin, sometimes it's percent of the total. So we're going to say, for example, %10 of, can someone tell me what 10% is of? 10% of what?
10% of
Yeah, this is 10% of snowy days. 10% of
snowy days above average.
snowy days have what? Is in the one, so that's above average temperature. Have above average temperature. To keep it one sentence, let's use the conjunction and 80%. Can someone finish this phrase for me? 80%. Chad, you want to give this a go? 80% of what?
80% of rainy days were above average
Yes. Well, above average in what?
temperature.
Yes. So, and 80% of rainy days had above average temperature. That's the end of the second sentence. What will the third sentence be? Gotta move this camera down a little bit so we can see it. What is the third sentence? Maybe you're pretty sure that you don't have it, but you just like a certified authority figure to publicly confirm that your answer is not correct. And I'll give you some feedback. What is the third sentence going to be? Josiah, do you know how it starts out?
Probably Sophia 59%.
Do you have, you know what, you can use as an example. Do you have the three sentences from, I think, Friday's lesson?
Yeah.
Because you can use parallel construction. So this same kind of construction you had, the same structure that you used on Friday, you can use it here.
I don't know.
Not sure, can someone help me maybe like just the first few words of this? Okay, Val, go ahead.
If weather were not associated with temperature.
And let's say had weather. Now, did you use language of association or the language of independence?
Association.
Okay, so say that sentence again, had weather, for that phrase.
Had weather not been associated with temperature.
Good, had weather not been associated with temperature. And then Josiah, can you tell me what then the rest of that phrase is? Or, I mean, sometimes.
Okay, so
Or can you tell me what you had in your notes for the rest of the third
says
sentence?
these two proportions would have been the same.
Yeah, so these two proportions would have been the same, and to be, I'd say even a little more specific, I don't know if we have this, but these two conditional relative frequencies, because they're not just any proportions, any percentages. So we can say, these two conditional relative frequencies would have been the same. Frequencies. Okay. Now, do you have any questions as to what the thinking is behind these three sentences? Okay, now we're going to go back even further. Instead of giving you the distribution of conditional relative frequencies, we're going to go all the way back to the counts. And we're going to change the context from Tempe, Arizona to Seattle, Washington. So this time you're going to have to come up with distributions on your own, but instead of vertically laid out distributions, I'm going to see if you can lay out the distributions horizontally. So if you have to go to the back side of this blank sheet of paper, you can. But this time, let's go to Seattle, Washington. And here we go. This time, I'm just going to give you the counts. It's still weather has one of three types. What was it, like snowy, rainy, whatever, it's the same three, 1 and 2, with 2 types of temperature. And suppose that of the days, the total, suppose 365 is what the census added up to, so 365. Let's say that of the 300 days in Seattle, Washington, A is raining. Well, it rains a lot in Seattle, so we're gonna say that 205 of them, of the 300 rainy days, 205 of them were above average and 95 were below average temperature. Of the 60 snowy days, we're gonna say 10 were above average, 50 were below average. And of the 5 dry days in Seattle, Washington, we'll go 2 and 3. So my question to you is, first of all, can you write, instead of the vertical distributions of conditional relative frequencies, this time, let's go horizontal. And how would this be different? Well, interestingly, we just did this earlier today. They didn't give you the marginal counts at the right. What do you do when they don't give you the numbers in the margin? Just add them up. 205 plus 12 is going to be 217. So if they don't give you the numbers you need, just do the adding to get them. So that's 98 plus 50 is going to be 148. Okay, so now that you have all the numbers you need, please fill in all 6 of these percentages. Basically find out what percent of the above average days were this type of weather, that type of weather, that type of weather. So fill in some, yes, go ahead.
So, when do you know to use horizontally or vertically?
You don't know, so the question is, when do you know whether to use horizontal or vertical? The answer is, it doesn't matter. You've got to know how, you've got to pick one and go with it.
So you basically just,
Pick one
either
and
way is
commit.
fine just to find a relationship.
Yeah, you can answer the independence or association question either way, but you just have to pick one and go with it. By the way, has someone already done 205 over 217 and converted 2%? Something like this. One more time, just a little bit louder. 94? 94% of the above average days were rainy, snowy. What does this come out to? Just for the sake of time, go ahead and call out the next 2 numbers. 5% and 1%. Okay, who has this triplet down here? Maybe you've already done it. Yeah, go ahead, Chan.
64, 34, 2.
Okay, so this is twice. I mean, yeah, these are clearly not the same, but for the example thing, wow, okay, that's the biggest difference right here, 5 to 34. This is like almost 7 times as big. So I'd like you to write your 3 sentences, but focus on, when it comes to the example, include 5%, 34% in your example. So try it. See if you can write out the 3 sentences. Oh wait, we only have 4 seconds left. So hopefully, you would say that they're not associated. In the example, you would say 5% of above average days were snowy and 34% of below average temperature days were snowy. Had weather and temperature been independent, these 2 conditional relative frequencies would have been the same. So the homework is due tomorrow, and you'll have to, for part B, you have to write out all 3 sentences for a different context. You are dismissed.